Now that we understand how to solve proportions, in this section, we're going to apply our knowledge to solve various real-life scenarios that we might encounter that involve setting up proportions. So this idea of setting up proportions in real-life scenarios is essentially we take two ratios and we set them equal to each other. Don't look too hard into this visual I have provided, because we'll work through a lot of examples in this section, word problems, so that way you can get familiar with how to set up proportions with word problems. Alright, so using the examples provided, set up a proportion based on the word problem. Then solve for the unknown value and round to the nearest hundredth if possible. So if we don't recall, remember to round to the nearest hundredths place means that we're going to round to the second decimal place. So I'm just going to write that here. Recall the hundredths means second decimal place. Alright, so for problem number 1, we have Jasmine bought 32 kiwis for $16. I wish kiwis were that cheap. How many kiwis can Lisa buy if she has $4? Well, to solve this, I'm going to first write this ratio out here. So we have 32 kiwi for every $16. So that means for every $16 Jasmine spends, she can get 32 kiwi. Or for every 32 kiwi that you buy, you'll have to spend $16. Now we want to know how many kiwis can Lisa buy if she has $4. Well, this ratio, now we're going to set this up as X kiwi, because that's what we want to know, how many kiwi for every $4 can we get. So let's set these two ratios equal to each other in a fraction form and solve for X. So we have 32 kiwi for every $16. We're going to set that equal to X kiwi over $4. Now, let's just cross multiply and solve for X like we did in the previous section. So we're going to get 32 times 4 equals 16x. Now, 32 times 4 is 128. And we're going to set that equal to 16x. Now to solve for x, we're going to divide 16 on both sides. And we get x equals 8. Now, x equals 8 what specifically? Recall x equals 8 kiwis. So for every $4, you can get 8 kiwis. Alrighty, looking at example number 2, we have the currency in Mexico is the peso. The exchange rate is approximately $1 or $1 US dollar for every 18 pesos. At this rate, how many pesos would you get if you exchange $121.10? Now, actually, I did look this up. It's technically like 17 point something, but I just rounded up to 18 pesos. So this would be, then when we solve the problem, you'd get a little bit more than you'd actually get, but it's relatively accurate. So we know for every $1 US dollar, we get 18 pesos. Now we want to know if we exchange $121.10, how many pesos would we get? Well, let's set up our proportions. So we know for every $1, we have 18 pesos. And then we're going to set that equal to $121. 1.10 over x. Now let's cross multiply and solve for x. So we have 1 times x, which that's just x. And this equals 18 times 121.10. Well, we get x equals 18. We get x equals approximately, well, actually, this answer only goes up to the first decimal place. So we're not going to do any rounding. And we get 2,179.8 pesos. That's your answer. That's how many pesos you'd get for $121.10. Now for example number 3, I encourage you to pause the video and work through this problem on your own. And now let's work through it together. So we have the ratio of boys to girls is 3 to 2. If there are 12 boys, how many girls are there? Well, we're told here that the ratio of boys to girls is 2. So we know that for every 3 boys, for every 3 boys, we have 2 girls. Then we want to know if there are 12 boys, using that ratio, how many girls would there be? So let's start up our proportions. So we have 3 over 2, 3 boys for every 2 girls. We're going to set that equal to 12 over x. Now let's cross multiply. 3 times x is 3x. 12 times 2 is 24. Now let's divide by 3 on both sides to solve for x. We get x equals 8 girls. That's your final answer. Looking at example number 4, we have a cyclist travels 27 miles at 1.8 hours. At that same rate, how long would it take the cyclist to travel 64.8 miles? So from now on, I'm actually not going to write out these ratios like this. I'm just going to start by setting up the proportion right away because we've seen a couple of examples. If you would like, you can definitely still write out these ratios if it helps you, but just due to time concerns, so this video doesn't become really long, I'm just going to start by setting up the proportion. So we know for every 27 miles, the cyclist will travel 1.8, or for every 27 miles traveled, 1.8 hours will have passed. So now we want to know how many hours will it take the cyclist to travel 64.8 miles. Well, let's find out by cross multiplying. So we get 27 times x equals 1.8 times 64.8. Well, we get 27x, and then 1.8 times 64.8 is 116.64. Now to solve for x, let's divide by 27 on both sides. And we get x equals 116.64 is approximately, here, let me write my approximation sign better. This is what approximately looks like. X approximately is 4.32 hours. So it'll take the cyclist approximately 4.32. For number 5, we have the number of bacteria in a culture is proportional to time. After 6 hours, there are 48,000 bacteria or bacteria cells. If the growth rate increases by 15% after hour 6, how many bacteria will be present after 10 hours? So this problem is a little bit more involved. So let's first start by boxing the question. Whenever you have problems that are a little bit more involved, I really encourage you to box the question so that way you the question really jumps out to us and it's very clear of what's being asked. And then I encourage you to also underline important information. So we know after 6 hours specifically, there are 48,000 bacterial cells. This underlining box kind of got in the way, but and then we also have if the growth rate increases by 15% after hour 6. And also looking at the first sentence, we have the number of bacteria in a culture is proportional to time. That's nice to know, but actually in terms of actually solving the problem, we don't really need this information. So I'm just going to actually cross this out so we have less to look at. Okay, so we are told after 6 hours, there are 48,000 bacteria. So my first step is I want to know the how much bacteria we get in just 1 hour at the original rate here. So I'm going to do that by taking 48,000 bacteria cells and dividing it by 6 hours, because we have 48,000 bacteria after 6 hours. So to get the hourly rate, we do the number of bacteria divided by 6. And this ends up happening to be 8,000 bacteria per hour. Now that we have that, we can now set up a proportion. So we're going to set it up like this. So we're going to have some new rate. And then we're going to divide that by our old rate. And we know that our new rate increases by 15%. And by the way, when I say new rate, I mean our new rate is the rate between hours 6 to 10. Because we are told here that at 6 hours, this is our bacteria. And then after hour 6, it increases by 15% than what was before. So this new rate, we're going to have to set it equal to 115% because it's an additional 15%. And the old rate is the original rate, which is 100%, the normal rate. So now what we're going to do is we're going to have to figure out, we want to know, what we're going to have to do is figure out our new rate. How much bacteria are we producing per hour at this new rate? We found it here that our old rate is 18,000 bacteria per hour, but we need to figure out what this new rate is. So that's what X is going to be for this proportion. So to set this up fully, we're going to get X over our old rate, which we found that here, 18,000 bacteria per hour. Or not 18,000, sorry, 8,000. We're going to set that equal to 115. I'm not going to put the percent because technically writing percent will change the values a little bit. So we're just going to keep it like this, notation-wise. But if it helps you, you can write percent if you'd like. Alrighty, so we set up the proportion now. So now all we have to do is cross-multiply to solve for X. So we get 115x equals 8,000 times 100. That just ends up becoming, I'm at 8,000 times 115, my apologies. That just 8,000 times 115 ends up becoming 920,000. Now to solve for X. And then, my apologies, actually. So now, to solve for X, let's cross multiply. So we get 100 times X, so we just get 100X. And then 8,000 times 115, which that is 920,000. Now to solve for x, just simply divide both sides by 100. So we get x equals 9,200. Now, what does this mean? What does this mean? Well, recall earlier, I mentioned that x needs to be the new rate because we know the old rate, but in order to answer the question of how much bacteria will be present after 10 hours, we need to figure out this new rate so we can add this total bacteria from the first 6 hours. So this means this is the amount of bacteria that is produced in 1 hour with the new rate at an extra 15%. So this means bacteria per hour at new rate. So now that we know that this signifies now that we know that this means 9,200 bacteria per hour at the new rate, we need to multiply this rate by 4. And that is because we know that this old rate is only goes up to hour 6. So after hour 6, this new rate comes in. So we need to count for the fact that the last 4 hours, 10 minus 6, the last 4 hours, the bacteria is producing at this new rate. So to find the total bacteria, I'm going to write it in this box here. So to find the total bacteria, we're going to have to take that 48,000 and add it to 9,200 times 4. And when you do order of operations, so recall order of operations, you do multiplication first and then you add. And then when you do that, you get an answer, a final answer of 84,800 bacteria. There you go. Alrighty. Looking at example number 6, we have a meteorologist reports that the ratio of snowfall in January to the total snowfall during an average winter is 2 to 5. If 34 inches fell in January of the current year, find the predicted total snowfall for the entire winter. So, right, our objective is to find the predicted total snowfall of the entire winter. And we are given this ratio 2 to 5. Now what this means is that this means that 2/5 of all total snow per year occurs in January. I'm just going to write JAN to abbreviate January. But that's what that means, if that wasn't super clear. So, now that we know that, well, we can say, hey, this is a ratio, 2 to 5, so I can set up a fraction or a proportion and set that equal to, well, what are we going to set this equal to? Well, we're given that 34 inches fell in January. We want to know the total snowfall, and recall that 5 is the total and 2 is the amount of snow that occurs in January. So we're going to say that the numerator is 34 inches because that's how much snow fell in January. And we want to know how many inches in total will we get for that year in the winter, or predicted. So to do that, to solve for x, we're just going to cross multiply. So we're going to get 2x equals 5 times 34, which is 170. And then we're going to divide by 2 on both sides. And we get x equals 85. So that means for that year specifically, the predicted total amount of snow for the entire winter is 85 inches of snow. That's a lot of snow.